Now here's an example that happens to work the other way. Of course, these are very special examples that have to be just right so that you can compare it to a well-known series. This one is 1 over square root of n minus a half. So what we'd like to do is compare that to 1 over square root of n. I didn't have a constant multiplier this time, make it a little simpler. And 1 over square root of n, or 1 over n to the 1 half, is what that is equivalent to, diverges. The summation of it diverges since 1 half is less than 1. It's a p-series again, and the power is a half, and that's smaller than 1. Now, square root of n minus a half is smaller than the square root of n, and so the fraction is larger. 1 over square root of minus 1 half is larger than the square root of n. Have to think that through every time. If you make the denominator smaller, you just made the fraction larger. Like, say, 1/7 is bigger than 1/10. So, now that we know that it's the terms are always larger in the one that we're asking about, that's the a sub n that we're asking about, then we have a b sub n that diverges. It goes to infinity. Therefore, the series that we're looking at also diverges by comparison to that one. Now here's one that is a little harder. Question, does the summation n equal 1 to infinity 3 over 7 times 2 to the n minus 13 converge? Alright, so we could try to compare it to something like 2 to the n, or 1 over 2 to the n. But the problem is that minus 13, it's not larger than 2 to the n, even though it's times 7, because the minus 13 is subtracting from it. It's not adding to it like in the first example we had. So you could force it by trying to throw away enough terms that you're only looking at the ones where minus 13 didn't matter, and 7 times it was still bigger. But in general, you sometimes cannot figure out that it's actually necessarily larger looking at the denominator than a denominator of a known sequence. But it's almost like it. 2 to the n has got to be pretty close to 2 to the n. 7 times 2 to the n minus 13. This times 7 and the minus 13 shouldn't matter. The part that is really growing fast is the 2 to the n. So we introduced this thing called the limit comparison test. Alright, now we have two sequences, one that we know and one that we don't. Again, we'll say that we know a sub n, or we don't know a sub n, but we do know b sub n. Then, if the limit of their ratio, a sub n divided by b sub n, where we actually put in the formula on top and bottom, if it turns out to be a real number greater than 0, can't be infinity, can't be 0. If it's a real number, then either both of them diverge or both of them converge. So for an example of the one that we just looked at, we do think that we should be able to compare it to 1 over 2 to the n. So we put 3 over 7 times 2 to the n minus 13 on top, 1 over 2 to the n on the bottom, and we try to take the limit as n goes to infinity. First, simplify by reducing that complex fraction. So basically just need to multiply the times 2 to the n, since we're dividing by 1 over 2 to the n. So we have 3 times 2 to the n over 7 times 2 to the n minus 13. Now that looks like it goes to infinity over infinity, so we want L'Hopital's rule. Of course, it's really okay to leave it as an n, but I like to write in the x to make it more official. So I take the limit as x goes to infinity, and then I take the derivative on top and the bottom. So derivative of the top is 2 to the x times natural log of 2. The derivative of the bottom is 2 to the x, and I of course keep the constant multipliers 3 and 7, times natural log of 2, and the derivative of 13 goes to 0. And now you can cancel log 2 over log 2 and 2 to the x over 2 to the x, and you're left with 3/7. So that's a real number, not 0, not infinity. It converged, and that means that either both the sequences diverge or both converge. But now you have to look and tell, what you know about the well-known sequence. So the well-known sequence was 1 over 2 to the n. That is a geometric series. It's one of the very first ones we looked at, the square that you can chop up into half plus a fourth plus an eighth. It converges by geometric series. So our unknown series, the one that we were looking at, 3 over 7 times 2 to the n minus 13. What was the original? Yeah, there it is. That one converges too, because they both do the same thing, since the limit of their ratio is a real number, not 0.